So this lesson is going to be on completing the square. So this is another way of finding a equation's turning points, but it's particularly useful for when you don't have a parabola that doesn't cut the x-axis. Like this one here won't cut the x-axis, therefore we wouldn't be able to find the roots, and then we wouldn't be able to find the central the axis of symmetry with the turning point occurred. So this is why it's quite useful. So I'm just going to go ahead and solve this. I'm going to run you through what I'm doing, but I'm going to go on to do more examples. So this is how you complete the square. So you want to take out any common factors first. So you take out this 2, and you have x squared minus 4x plus, and you just divide everything by 2 if it doesn't divide. Okay, so that's your first step. And your next step is you want to get all the x terms in one squared bracket. Okay, so what you do is you take your x, and then depending on what this sign is, you'll just carry that sign over, which will be minus, and you want to take half whatever this value is. So this then becomes 2, and you square that whole bracket. Okay, and to compensate for halving it and putting it in this bracket, what you need to do is you need to take away the square of what you just halved. So you take away the square of what was in here. So in this case, it's 2. So minus 4, because 4 times 2 squared is 4. So minus 4 plus 9 over 2. Okay, then you just simplify out the brackets. This becomes 2x minus 2x squared. There should be another, I think there should be, yeah, I'm missing a bracket in here. And there. Minus, well, 4 over 2, 9 over 2 is just 4.5, so minus 4 is just 1 over 2. So it multiplies the whole thing out, it becomes 2x minus 2 all squared minus, plus 1 even, plus 1. So that should be plus a half. Okay, so how does this help us here? How is this any different than where we were before? Well, actually what happens is we know that the smallest this bracket can ever be, okay, the smallest it can ever be is 0, right? Because of this squared term, the smallest we can make it is 0. Okay, so this could be 0. And when we make this 0, what are we left with? We're going to be left with this 1. So we know at the minimum point of this, this parabola is going to be positive 1. Okay, and we know it's the minimum point because it's a positive x squared. So here, we know that that's the minimum point. Okay, so 1. Okay, and now how do we how else does this help us? Well, if we want to make this the minimum point, then what do we need to make x to make this bracket 0? Well, we need to make x positive 2 to make this bracket 0 to find the minimum point. So this is just becomes 2. Okay, and what about cutting the y-axis? When will that happen? Well, that happens when x is equal to 0. So look, you can either, if you put 0 in there, you get 2 times 4, which is 8, plus 1, which is 9. But also, if you look back to the original equation, you could just put 0 there and get 9. But they're both correct ways of doing it. So you have 9 up there. Okay, and then your parabola just, this looks like this. Okay, whereas before we wouldn't have been able to work out the sketch of the graph without the roots, but obviously this one doesn't have any roots, so it's just a different way of doing it.